Good morning, everyone, and welcome to this lecture. In this lecture, we'll deal with EM waves or electromagnetic waves. So, let us start with the topic. What do you understand by EM waves? And what are the things that we have to understand here? Now, we have seen the basic equations of electromagnetism. We started with electrostatic field, then we moved on to magnetic field, and we saw various equations that are there. I hope you remember them. The first equation that we saw, I think this one. Surface integral of E dot E dot ds is charge enclosed divided by epsilon naught. Do we remember this equation?
Yes.
That was known as the Gauss law for electrostatics. We use this Gauss law to find out the flux through any closed surface. This circle denotes that it is integral over a closed surface. Do we remember this equation?
Yes.
Then we saw the counterpart of this. The counterpart of this is this one. Write them in vector form. That would be good. E dot ds. The surface integral of B dot ds over a closed surface. Gauss law for magnetism, it is equal to 0 because magnetic monopoles do not exist. If you create a closed surface, either it will enclose both the poles of the magnet or it will not enclose any pole. Do we understand this?
Yes, sir.
So the Gauss law for magnetism looks like this. Then you can create a Gauss law for gravitation as well. Can you tell me what will be the Gauss law for gravitation? Gauss law for gravitation, G dot ds. The surface integral of G dot ds is minus 4 pi capital G into m, where this capital G is the universal gravitation constant, small g is the gravitational field, and m is the mass enclosed by the surface. This is Gauss law for magnetism. We don't require it, but since we were writing it, I have written it. Then the third law that we saw, these were surface integral. Then we moved on to line integrals, and the line integral of electric field E dot dl over a closed loop, that becomes equal to 0. This is, you can call this as Ampere law for electrostatic. This was also your loop law, voltage law or loop law that we saw in electric current. Do we remember this?
Yes, sir.
Then we saw the fourth variation of the same thing. What was the fourth one? I mean, fifth one now. Actually, in electromagnetism, it's the fourth one. What was the fourth one?
Biot's outflow.
It was Ampere's law for magnetism. B dot dl का integral will be equal to mu naught into I, where I is the current enclosed in the loop. Now these were the four laws. The fifth one is for gravitation. These are the four laws that we studied. Now these four laws that we studied were only valid when we had constant electric or magnetic field. When I say constant electro or magnetic field, that means they were not time varying magnetic fields or time varying electric fields. These four laws, the fifth one is just the gravitation law, which we are not including here. These four laws are the laws which are valid when the gravitational field, when the electric field or the magnetic field are not time varying. We have already studied that. I'll give you a minute to note this down. Now we had seen one case where we had a time varying field, in which case we had a time varying field. We had a time varying field. We had seen the time varying field. Do you remember that time varying field? Which one was that time varying field?
Magnetic field.
It was a time varying magnetic field. And when we had a time varying magnetic field in a cylindrical space, very specifically, what does this time varying magnetic field give rise to? A time varying magnetic field gives rise to an electric field. Do we remember this?
Yes, sir.
A time varying magnetic field. A time varying magnetic field. A time varying magnetic field gives rise to an electric field. Yes or no?
Yes, sir.
Now, this electric field was non conservative in nature. Yes or no?
Yes, sir.
This electric field was non conservative in nature. This electric field was non-conservative in nature, and for this electric field, the line integral of E dot dl over a closed loop was not equal to 0. In fact, that was equal to minus the minus the rate of change of magnetic flux. Yes or no?
Yes, sir.
That means the line integral of E dot dl is not equal to 0. It is only equal to 0 for a conservative electrostatic field. For a time varying magnetic field, that E dot dl is not equal to 0. Do we understand this?
Yes, sir.
That means this equation that we see, this e oops, this equation that we see, this equation that we see comes into the picture for a time varying magnetic field. Yes or no?
Yes, sir.
Time varying magnetic field. So a time varying magnetic field, a time varying magnetic field will give rise to a electric field. I'll give you 2 minutes to note this down. We now know that a time varying magnetic field, which will change magnetic flux, that will create an electric field and which is non-conservative in nature. Now, a time varying magnetic field gives rise to an electric field. That is what we can see, that is EMI, electromagnetic induction. Now, as soon as these facts come into the picture, that a time varying magnetic field can produce an electric field, there is one question that comes to our mind. What will be that question that comes to our mind?
What if there is time varying electric field?
What?
What if there is time varying electric field?
What is there if there is time varying electric field? Can a time varying electric field also produce magnetic field? And the answer is an astounding yes. A time varying electric field does produce a magnetic field. Now, the best way to understand this concept is to look at the charging of a capacitor. Here you can see a parallel plate capacitor is made, not a very good diagram, but these are the two plates of a parallel plate capacitor, and this parallel plate capacitor is connected to a battery of voltage V, and at time t is equal to 0, the switch is switched on. Initially, the capacitor is completely discharged, it's having no charge. The switch is switched on at time t is equal to 0. Now, as soon as the switch is switched on at time t is equal to 0, there are two magnetic needles kept, one which is kept close to the wire, one which is kept in between the plates of the capacitor. Now, what do you see? This magnetic needle 1 as well as this magnetic needle 2. As soon as the battery is switched on, the switch is switched on, both of these magnetic needles or magnetic compass, they show deflection. Now, the deflection in the needle 1, which is here, can be understood because it is coming because of the current flowing in the wire. Yes or no?
Yes.
But then how do you explain the deflection in the magnetic needle 2? The deflection in the magnetic needle 2 is coming because of what? Because of what? The deflection in the magnetic field, the deflection in the magnetic needle
Between the plates.
is coming because of
Electric field between the plates.
is coming because of the electric field between the plates is changing. Electric field between the plates is changing. Do we understand this?
Yes, sir.
And hence he concluded that a changing electric field with time also produces its counterpart magnetic field, and the entire puzzle gets solved. And this changing electric field, here we have understood in terms of charging of the capacitor. Wherever electric field is changing in time, it will give rise to a magnetic field. Do we understand this?
Yes, sir.
I give you 2 minutes to note this down. You don't have to note this down everything. You just have to draw a simple diagram, write it in your simple language. A changing electric field. Basically, what you have to understand is a changing electric field with time. Changing electric field with time gives rise to a magnetic field. This is all that you need to know, and this process can be understood. It can be seen when a capacitor is getting charged. I'll give you 2 minutes to note this down. So now you can write Ampere's law for the two space outside the capacitor space, outside the capacitor plate. You can see that the integral of B dot dl will be equal to mu naught into IC. You call this IC as the current which is flowing due to conduction, current which flows because of potential difference. We call it the conduction current. Do we understand this?
Yes.
This is the line integral produced because of current which is flowing in the wire. In between the capacitor plates, you can write the equation for for integral of B dot dl like this. Mu naught into epsilon naught into d phi E by dt. D phi E by dt becomes the rate of change of electric flux with time. Do we understand this?
Yes.
So you can produce magnetic field by two ways. Either you can flow a current in the wire that will produce a magnetic field, or you can change electric field with time. If you combine these two equations together, you will get an equation like this. Yes or no? No, yes.
Yes.
The first current is the conduction current, normal current. The second one is also just like current. We don't call it conduction current. We cannot call it conduction current. So we have generated a new name for this, and this term is known as the displacement current. So welcome to the last part of this chapter. Welcome to the last term of this chapter, which is known as displacement current. Do we understand this, or this has gone above our head? Saying bye bye.
Understood, sir.
I'll give you 2 minutes to note this down. Displacement current, the next term, the last term. So now you have modified equations, which and we call them modified Maxwell's equation, because Maxwell wrote them in this fashion. And the modified Maxwell equations, the first equation, integral of b dot ds, remains same, that does not change. Integral of the surface integral of b dot ds over a closed surface still remains equal to the charge enclosed divided by epsilon naught. The second equation, b dot ds, surface integral over a closed surface is equal to 0. The third equation changes. Because it is also taking into the picture the time varying electric field. Time varying electric field gives rise to a magnetic field. Do we understand this?
Yes, sir.
The fourth equation now also takes into the picture a time varying, the third equation was time varying magnetic field gives rise to electric field. The fourth equation has time varying electric field giving rise to magnetic field. Yes or no?
Yes, sir.
This I is the conduction current and this one is the displacement current. Yes or no?
Yes, sir.
Some people also write this equation like this, ID, IC plus ID. Do you understand the meaning of IC and ID?
Yes, sir.
IC is the conduction current and ID is the displacement current. For free space, there are no charges and there are no conduction current. So you can write equation number 3 and equation number 4 in this fashion. Only what I have changed here is in equation number 4, there is no current. So that conduction current wala term goes away. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. So now I have these two equations, the equation of E dot dl, which is produced by a time varying magnetic field, and the equation of B dot dl, which is produced by a time varying electric field. These two are differential equations, and when we solve these differential equation, it gives us the value of electric field. This electric field and magnetic field are mutually perpendicular to each other, and these are the equations. E naught and B naught are the amplitudes of these electric and magnetic fields. C is the speed with which this electric field is with this wave is moving, speed of this wave, and that C becomes the speed of light, which is the speed of electromagnetic waves. 1 by mu naught epsilon naught ka root is also equal to C. Welcome to EM waves. Do we understand this?
Yes, sir.
What we have to understand here is both of these electric and magnetic fields, they are not in the same direction, they are mutually perpendicular to each other. Do we understand this? Yes or no? No, yes.
Yes, sir.
I'll give you 2 minutes to note this down. EM waves, electromagnetic waves. A changing electric field produces a changing magnetic field, and vice versa. A changing magnetic field with time will give rise to a changing electric field. Yes or no? That's
Yes.
it, my dear friends. They will give rise to EM waves. Electric field and magnetic field are perpendicular to each other. They are also perpendicular to the direction of propagation. See the velocity. So all these three vectors are perpendicular. The electric field, the magnetic field, and the direction of propagation. Do we see this? Yes or no? No or yes?
Yes, sir.
EM waves. These are the EM waves. How do you produce EM waves? Number one, an oscillating or accelerating charge. An accelerating or accelerating charge will produce EM wave. Yes or no?
Yes.
Uh, LC oscillator. We have not seen this LC oscillator. A LC oscillator will produce EM wave. Remember this, a LC oscillator produces a EM wave. EM waves are also produced. EM waves. X-rays are also EM waves. EM waves are also produced when fast moving electrons are suddenly stopped by a metal of high atomic number. So these are the three different ways in which you can produce electromagnetic waves. What are the properties of electromagnetic wave? You must have a changing electric field, which will give rise to a changing magnetic field. A changing magnetic field will give rise to a changing electric field. And because of this, you will have electric and magnetic field in perpendicular direction and perpendicular to the direction of the velocity or the direction of propagation. To produce an EM wave, we need an oscillating or an accelerating charge. It can also be produced by an LC oscillator. It can also be produced. X-rays are also electromagnetic waves. Fast moving electrons, when they are stopped by a metal, we also have EM waves. These things are coming, so please note them down very carefully. Do we understand this?
Yes, sir.
Remember, whenever we are talking about an LC oscillator, they may ask you a question, what is the frequency of the electromagnetic wave produced by an LC oscillator? So remember, the frequency of EM wave produced by an LC oscillator is 1 by 2 pi root over L by C. Now 1 by 2 pi root over L by C will remind you of something. What it should remind you of? I'll give you 2 minutes to note this down. And remember, there is one confusion, and they have asked this question many times. In an atom, the electron is moving in a circular orbit around a nucleus. It is moving with a constant speed, but it has an acceleration because it has centripetal acceleration. It is moving in a circular path. It is accelerating, so it must produce EM waves when it is moving in a circle, moving in this orbit. But remember, when it is moving in this orbit, it does not produce EM wave. It does not produce EM wave when it is moving in this circular orbit. It only produces EM waves when it jumps from higher to lower, or you make it jump from lower to higher. So electron moving in a nucleus does not produce EM waves. It only produces EM wave when it is making a transition from lower to higher or higher to lower. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Then we can understand this nature of EM waves, light waves, any radiations are EM waves. They are transverse in nature. The electric and magnetic field are perpendicular to each other, which is perpendicular to the direction of propagation of wave. We call them transverse in nature. They do not require any medium. Light or EM waves can travel in vacuum. Do we understand this? Yes or no?
Yes, sir.
In free space, the what? The speed of light is 3 into 10 raised to the power 8 meter per second, and that is nothing but equal to root over 1 by mu naught into epsilon naught. I told you mu naught and epsilon naught are related to each other. Yes or no? No or yes?
Yes, sir.
In any other medium, if you go, the speed of that light, no, sorry, the speed of the electromagnetic wave in this medium will be 1 by root over mu naught into epsilon, where mu naught and epsilon naught relative permeability and permittivity in that space, not relative, the permittivity of the medium and permeability of the medium. Do we understand this?
Yes, sir.
The energy, and I have seen this question come very frequently these days, the energy density of electric field and energy density of magnetic field is equal. That means in a EM wave, energy is equally distributed. Do we understand this?
Yes, sir.
The total energy density or average energy density of the total field will be the sum of these two. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Then you can note down these formulae. Question based on these formulae are in fashion these days. If you know, then only you can do them. Else, bye bye. Intensity is the energy per unit area per unit time perpendicular to the direction. Did I tell you that? Yes or no in waves? In the chapter on waves, I told you about intensity of a wave. Yes or no?
Yes, sir.
This is also electromagnetic wave. This is how you can find out the intensity. You find out the average energy and multiply it by C. Do we understand this?
Yes.
This is how you can find out momentum. Every wave carries momentum, and the momentum of that wave, P, remember this formula, very important formula. Momentum of a wave is P divided by C, or V. Sorry, H divide. What I've written? Why I've written H? Momentum of any wave, traveling wave, is given by E divided by C if it is moving with the speed of light. If it is not moving with the speed of light, E divided by the speed of that wave. Do you understand this?
Yes, sir.
If an incident wave is falling on a surface and it is getting completely absorbed, it's not getting reflected back, the momentum it will impart will be U by C. Yes or no?
Yes, sir.
U means, don't get confused, U is the energy E. U is not the velocity. If it is getting completely reflected, so the change in momentum will be 2 times U by C. Yes or no?
Yes.
2 times E by C. Yes or no?
Yes, sir.
That is the momentum imparted by a wave which is reflected completely or completely absorbed. I'll give you 2 minutes to note this down. And we come to the most important aspect of this, in which most of the questions are framed these days. It is the pointing vector as vector. Obviously, they are not going to ask you what is the pointing vector, because pointing vector is actually not a part of your course. Pointing vector basically tells us the rate at which energy is flowing through a unit area. Its unit is watt per meter square. Basically, this is the formula for pointing vector. S vector is 1 by mu naught into E cross B, or you can also write it as C square epsilon naught into E cross B. They are probably not going to ask you this formula of pointing vector, but this pointing vector tells us the direction of this pointing vector tells us the direction of this pointing vector tells us the direction of the propagation of wave. It tells us the direction of the velocity of the wave, and this is very important in finding out in which direction the wave is moving. There could be a question where they give you the value of magnetic field and they ask you where is the electric field, whether it is along X, Y, or Z. If you know where is electric field and magnetic field, you can find out in which direction the velocity is. If you know in which direction the electric field is and in which direction the velocity is, you can find out the magnetic field, the direction of magnetic field. These three are perpendicular to each other, and the velocity or the pointing vector is in the direction of E cross B. Do we understand this?
Yes, sir.
That will give you the direction of the velocity, and from there you can find out what are the direction of these three vectors. Questions based on this have come many a time. So that is what you need to understand. The fourth thing is the radiation pressure, the pressure exerted by the wave, it is getting completely reflected. It is 2s by c. If it is getting completely absorbed, 2s by s by c. It comes directly from the momentum part. Rate of change of momentum is force. You divide it by the area, you get the pressure, and that is how this thing is achieved. Remember all these formulas. Any formula can save your life. Do we understand this?
Yes.
Because you can have a question based on any of these formulas. If you just remember one formula, you should be able to formulate the other ones. I hope I am making sense. Yes or no? No or yes?
Yes, sir.
You have 2 minutes to note this down. Well, then there is this question that you need to solve. A plane electromagnetic wave whose frequency is given as 25 megahertz is traveling in free space along x direction, that means positive x-axis. At a particular time in space and time, the electric field is given. What is the magnetic field? You have to tell me the magnitude of magnetic field and also the direction of magnetic field. I hope you can tell me that. I'll give you 2 minutes to give me the answer. So how are we supposed to do this? Can anyone say anything? Do you know it or not?
Sir, E by B is equals to C.
E by B is equal to C. Okay, then E by B is C. So from there you can find out the value of what? Okay, you cannot find out anything. Well done. E by B is C. So from there you can find out the value of B. B is E by C. You multiply B by C. 6.3 divided by C. 3 into 10 raised to the power 8. I hope you know the speed of light. And if you do that, you will get with 2.1 into 10 raised to the power, I think, minus 6 Tesla. That is, sorry, minus 8 Tesla. That is the value of the magnetic field. That was the first part of the question. You just have to find out the direction of magnetic field. The direction of magnetic field, how you will find out the direction of magnetic field? Obviously, you don't know it. So you have to find out the cross product of E and B. The cross product of E and B should be in the direction of the propagation. This is J. This is in the direction of J. You don't know what is the direction of B. J cross B should be in the direction of I. Now, how can J cross B in the direction of I? When this J is crossed with K, then only you will get J cross K is I. So the value of magnetic field or the magnetic field vector becomes 2.1 into 10 raised to the power minus 8 K. And that is the answer that I was looking at. I'll give you 1 minute to note this down. Well done. Then this is a question that comes from previous year paper. This is from the paper of, I think, 2020. A plane electromagnetic wave of frequency 100 megahertz is traveling in vacuum along the x direction. X direction. At a particular point in space and time, see, exactly same question. Magnetic field is given as 2.0 into 10 raised to the power minus 8. Exactly same wording. K is the unit vector along Z. What is the value of E at that point? So, it has to be in the direction, this is in the direction of K, this is in the direction of X, so it has to be in the direction of J, so this and this goes away, and to find out the magnitude of electric field E, that will be equal to B multiplied by C. So it is as simple as it gets, and the option is this one. Do we understand this, or this has gone above our heads? Saying bye bye. I'm going bye bye. I'm going bye bye. I'm going bye bye.
We understood.
Thank God. What is great that we understood this. Remember, a question is definitely going to come from this particular topic, and that is why I'm doing this as a sure short question. A sure short question. So I'll try to do all types that are possible. This is the next one. A plain electromagnetic wave of frequency 500 megahertz is traveling in vacuum along y direction. The magnetic field at a particular time is given. What is the value of electric field? Yes, do you have any doubts?
Sir, in the previous question, what is there to do with frequency, sir?
Chill. Here comes the next one.
Option 1.
Option 1. And option 1 is the answer. How are you supposed to do this? Electric field magnitude will be given by B multiplied by C. If you multiply B by C, I think you are going to get 24. So the only options that may be correct are option number 1 and option number 3. So you basically have to find out whether it will be in the direction of plus x or minus x. How will you find it out? Remember, E cross B should give you the direction of C, the direction of propagation. Now, E you don't know, so you write E as E cross. The direction of magnetic field is K. That should give you the direction of J. What cross K will be equal to J? You ask yourself this question and you will get your answer. What cross K will be equal to J?
Minus I.
Minus I, and therefore minus 24 is the answer, my dear friends. I hope we are making sense of this. Here comes the next one on this. A plain electromagnetic wave propagating along Y can have the following pair of electric and magnetic field. Sir, it is option 3. Yes, sir, because Y, wave is along Y. So electric field and magnetic field has to be along X or Z. There's only one option which shows that, and that, my dear friends, is the correct answer. Well done. That takes us to the next one. Next one is this one, my dear friends. In an electromagnetic wave, the electric field and magnetic field vectors are given by this. What is the direction of propagation? Option?
4.
Option 4, you just have to do I cross K, and I cross K will end up with minus J, and that is the answer that we are looking at. Do we understand this?
Yes.
This one. Give you 2 minutes. How do you get the value of X? C is E by B. So B becomes E by C and you get your answers. Do we understand this? Yes or no? No, yes.
Yes.
Okay, so we'll come back to these questions. Let us first Okay, I can start from here. This one, electromagnetic wave of frequencies 3 gigahertz enters a dielectric medium of relative dielectric permittivity 2.25 from vacuum. The wavelength of this wave in that medium would be how much? So how are we going to do this question? Remember, the frequency of the light or frequency of the electromagnetic wave remains same. Yes or no?
Yes.
We know that in any medium, V is equal to F lambda. Yes or no? Lambda in any is F by V. V by F frequency remains constant. So lambda is directly proportional to the speed of light. Yes or no?
Yes, sir.
Lambda in a medium will be directly proportional to the speed of light in that medium. Yes or no?
Yes, sir.
So from there you can find out the relation between lambda m and lambda. Lambda in any medium will be lambda in vacuum or lambda in air divided by mu, where mu becomes the refractive index. Do we understand this?
Yes, sir.
Now, this refractive index mu can be found out by this formula, and this is the formula I needed to give you. Mu r into epsilon r, where mu r is the relative permittivity and permeability, and epsilon r is the relative permittivity. Now here I assume that this is a non-magnetic material, so I assume mu r now again this mu would be giving you this mu that I am using is the refractive index. Do we remember this refractive index?
Yes.
This mu is the refractive index, and this mu r is relative permittivity, and this is the relation between refractive index and relative permittivity and relative permeability. Do we understand this?
Yes, sir.
Remember this relation. This is the reason why I had given you this. So I assume mu r is equal to 1, and mu epsilon r is given as 2.25. So your refractive index mu becomes the root of 2.25, which is 1.5. So that is what you were supposed to know from this question. So once you get the value of refractive index, you should be able to find out the wavelength in that medium. So two things you have to remember from this discussion. How do you find out the wavelength of the wave in any other medium? And how do you find out the refractive index of any medium? So these are the two things that you have to note. Have you noted it down? Two things. What are the two things that you had to note? The first thing is the value of lambda in any medium is lambda in air divided by mu, the refractive index, and the refractive index is root over mu r into epsilon r. So this will be equal to root of 2.25, that is 1.5. So now you can calculate lambda in the medium. Lambda in the medium will be lambda in air. How will you find out lambda in air? V is equal to F lambda is given. So lambda in air we know that the speed is the speed of light. So it is 3 into 10 raised to the power 6 gigahertz. Oh, giga is 10 raised to the power 9, I think. 10 raised to the power 9 giga. And then we divided by the speed of light. 8 divided by, I'm getting confused with this. So speed of light divided by the frequency, that will give you lambda in air as 0.1. You divide 0.1 by the refractive index. The refractive index is 1.5. So the wavelength in the medium will be 0.1 meter divided by 1.5, whatever the answer comes. Do you understand how this question is done?
Yes, sir.
I'll give you 2 minutes to note it down. Note it down and understand what we have done and the formula that we have to remember. Let me move to the next question. And I see this one. Let me see if you can do this. Let's see if you can do this. The peak electric field produced by radiation coming from an 8-volt bulb at a distance of 10 meters is given by this formula. The efficiency of the bulb is 10% and it is a point source. What is the value of X? So how are we supposed to solve this question? You know the formula of intensity at any point? I just gave you the formula. What was the formula of intensity of EM wave? What was the formula of intensity of EM wave?
Half epsilon naught square or half epsilon naught into E square into C.
Half
Epsilon naught into E square into C.
half epsilon naught C into E naught square. Yes or no?
Yes.
Now the peak value of electric field is given by this formula. So we just add it, half epsilon naught C into E square will become X square by 100, yes or no?
Yes.
Into mu naught into C by pi, yes or no?
Yes.
Now remember, this mu naught into epsilon naught is 1 by C square, yes or no?
Yes.
Yes or no?
Yes.
So this will cancel out everything, right? This will cancel out, right or no?
Yes.
So your thing will be x square by 200 pi, yes or no?
Yes.
Now you have a point source of power P, and you have to find out the intensity at this point, the distance of this point from the power source is R. If you remember, sometimes back I gave you the intensity created by a point source. The intensity created by the point source will be P divided by 4 pi R square. Yes or no? No, yes.
Yes.
But here one more term has been added. It is 10%. The efficiency is given as 10%. So not all the energy is converted into light. So basically, if the efficiency is given as eta, you just multiply this by eta. So this intensity becomes 8 divided by 4 pi into 10 square into 10%. 10 by 100. Do we understand this, or this has gone above our head? Saying bye bye. Bye bye, I'm going. Bye bye, I'm going. Bye bye, I'm going. Gone above our heads?
No. Sir.
Have you understood this? So
Yes.
8 divided by 4 pi into 100 into 100 into 10. Pi and pi goes away. 101 go away. This is 2. This is 4. This is 4 by 10. 4 by 10 is what I am getting 0.4. So maybe there is a mistake somewhere. The answer should be coming as it is 0.4. So 0.4 ka root is 0.2. Is it so? So my answer is coming as 0.2. Do you understand how this sort of problem has to be done?
Yes.
Have you understood this?
Yes.
Pakka?
Yes, sir.
I'll give you 2 minutes to note this down. Remember the formula. Remember the formula of intensity. And remember the formula of intensity created by a point source. Intensity created by a point source. Efficiency is given as 10%. So multiply it by the efficiency. I'll give you 2 minutes to note this down. If you have understood this, then I'll give you one question for practice. Again, this is a question from previous years. These type of questions are coming, and that is why we are doing them. This is the question. The electric field intensity produced by a radiation coming from a 100-watt bulb at a distance of 3 meters is E. The electric field intensity produced by the radiation coming from 60-watt bulb at the same distance is x by 5 E. What is the value of x? Here the efficiency is not given, so we will assume that the efficiency will be 100%. Do we understand this?
Yes.
Now the electric field intensity produced by a 100-watt bulb, the electric field, the intensity is half epsilon naught C into E naught square, and that will be equal to power divided by 4 pi R square. Yes or no? Assuming it to be 100% efficient. Yes or no?
Yes, sir.
So I can see that this E is proportional to P root over P by R. Yes or no? Because rest all everything is constant. Yes or no?
Yes, sir.
So that's it.
R is also constant.
Here R is also constant. So you have electric field E2 by E1 will be equal to root over P2 by root over P1. Now 60-watt bulb divided by 100-watt bulb, E2 by E1 becomes root over x by 5. Yes or no? And that will be equal to root over 60 by 100. Yes or no?
Yes, sir.
So x by 5 is 6 by 10. I don't know from where you were getting the answer. I am getting a very sweet answer. X is equal to 3. Don't know what you have done. Have I done anything wrong?
Sir,
Yes.
I have forgotten that x by 5.
What have you?
I have taken x by 5 as x.
You can take anything in this semi-verse. That is your wish. Because remember, because of such mistakes, you will get -5 when you should have got +4. You lose 9 marks. And that is why you're sitting at where you are. Mistakes like this cannot be pardoned. And these are the mistakes that are going to get you down. And I can't help you. No one in this universe can help you with such mistakes, beta. Anyways, I have to move ahead in life. If you can't solve such simple questions, as I told you, your calculations on a scale of 0 to 10, I will rate them at -50 on a scale of 0 to 10. Your calculations are at -50. But that's not the case with you. That's the case with the 99% of the students who are appearing for JEE Main. Only 1% students are good at calculations, and that is why they come in the top 99 percentile. That is the only reason. This is the next one. I hope I get better answers for this one. You have to find out the value of magnetic field at that point. So you can use that formula half P naught square into C divided by 2 mu naught. Yes or no? No, yes.
Yes.
Now 1 by mu naught is equal to epsilon naught into C square. Yes or no?
Yes.
So intensity is half B naught square into epsilon naught C cubed. Yes or no? No, yes.
Yes.
That's it, my dear friends. From here, you should be able to calculate the value of B. B will be equal to 2I by epsilon naught C cube ka root. Now the question should come in this fashion, but I have seen this question has come in your JEE It's just a matter of calculation. And my dear friend, again, your calculations are wrong because the answer that I have is this one. And I'm not going to get into the calculation part because that is none of my business. To get into the calculation, I can't teach you calculation at this point in state. Definitely not multiply, divide, plus, and the square root. That is out of course for me. Anyways, I'll give you this question and then I'll complete a small theory part and then we will come back and solve the remaining questions. So this is the next one. For an electromagnetic wave traveling in free space, the relation between average energy density due to the electric field and the magnetic field is what? What, my dear friends, is the answer? What, my dear friends?
Option 1.
Option 1, both are the same. I hope we realize this and we understand this. Yes or no? No, yes.
Yes.
Then we move on to the last topic, last heading of this particular topic. Your electromagnetism is coming to a end here today. And very recently, in this year, we had a question on EM spectrum, the first session. EM spectrum. What is EM spectrum? Whenever we talk about spectrum, it gives us the what? The arrangement of waves or frequencies or light and all these things when they are arranged in an order of their frequencies or their wavelengths, then it is known as a spectrum. EM spectrum, it consists of all the waves that we have seen or we are going to see. This is your EM spectrum. Gamma rays has the minimum wavelength. Radio waves have the maximum wavelength. Wavelength is inversely proportional to frequency. So gamma rays has the most frequency and radio wave has the least frequency. There's nothing to explain here. You just have to remember this result. They might ask you what is the range. More frequency means more energy. So gamma radiation is the most harmful. X-rays are also harmful, but less harmful than gamma, then ultraviolet, then visible, then infrared, then microwave, and then a radio wave. I'll give you 2 minutes to note this now. There's nothing to explain here. You have to remember them. Nothing to explain here. You just have to remember these uses. One of these uses can appear in your exam and you will get -5 if you don't know this. The question I think came in this session. Some paper of this session. I'll try to find it out if I can. If I can't, well, I've seen it. And seeing is believing. Note it down. Nothing to explain. This is the question that I was talking about. 31st January. Shift 2. Yes. Any chances of getting the answer for this one? Or shall I let it go? +4 or -9. What are we going to get here? My bet is on -9. What is the correct answer for this one, my dear friends? Huh? No one knows anything. Well done.
Option 2.
Option 2. Chalo, God exists. Thank God, God exists. Thank God, God exists. Anyways, let me try my luck on the next question, whether God exists or not. This is 29 Chan shift 2. These are the type of question we expect in an examination hall. +4 or -9, straight away right. Just my dear friends, any answers for this one? Can I expect an answer for this one? Nah? No, sir, I don't have an answer, sir. I don't know, sir. I don't know what is EM wave, sir. Yes, sir. Obviously, no answer, sir. EM waves are not deflected by electric and magnetic fields. EM waves do not carry charge, so they are not deflected by electric and magnetic fields. And the correct answer is option 1. Electromagnetic waves are not deflected by electric and magnetic field, and the reason is they do not consist of any charge. So the option is A. Have you noted it down?
Yes.
That takes us to the next one, and there is again no explaining here. You just have to cut, copy, and paste. Keep it in your notebooks. Remember them. Stay happy. Then comes this question, sir. This is the question from your 2019 paper, and I am waiting eagerly for your answers, my dear friend. What is the answer for this one? Yes, my dear friends. Which one?
Option 4.
Option 4. Source of microwave is magnetron. That is there in option 3 and option 4. Option 3 and option 4 only differs in option C and D. Source of gamma rays is radioactive nucleus. Therefore, answer is option A. This is how you get +4 or -9. Do we understand this? Now this is gone above our head saying bye-bye. Bye-bye, I'm going. Bye-bye, I'm going. Bye-bye. Shall we move ahead in life?
Yes.
This is JEE Main 2023. 1st February, shift 1. Tung, 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 tung. +4 or -9 is the straight away answer. And if you are given this paper, this would be in your paper. Well, my dear friends, any hope of getting this answer? Or shall I give up that hope? Right? Any hope? No hope, sir. Please don't have any hope with us. We're all hopeless cases. Yes, my dear friends. No answers. Well done. Such a difficult question. If you can't answer it now, you will not be able to answer it in the examination hall. We did AC 2 days, 1 day back. Just 1 day. Just 1 day, my dear friend. Just 1 day. And the answer is no one knows how a AC generator works. An AC generator works on the concept of EMI, electromagnetic induction. Sharpness of resonance, go. We did it yesterday only. Yesterday, and we can't replicate it today. Oops. Q factor. Transformer. Yesterday, last class. Not even 24 hours have passed. And we are done. Anyways, these are the answers for this one. Well done. as expected on expected lines. I don't expect anything else from you. The only thing that you have to forget is the habit of forgetting things, and that is the only thing that you cannot forget. Anyways, here comes the next question. This is shift which paper? This is shift 2 of some paper. This is today's class only. I hope so. Any hope of getting an answer for this one? Or should I give up all hope? Sir, there is no hope. Don't keep false hopes on us. We are all gone. Cases? Or shall I expect an answer? Yes, my dear friends. Any answer? Coming from anywhere?
Option 1.
Option 1. Chalo. Option 1 is correct. E naught by B naught is C, and C is omega by K. God exists. I always start questioning the existence of God. But God does exist. It is evident from the things that happen around us that God exists. God exists. Then God gives questions like this also. And as I said, something, one question comes from one topic in one session, the same question comes from same topic in same session. 2023, 24 Jan, shift 1. This is the question, my dear friends. Any hope of getting anything that looks like an answer? Or no hope of anything that looks like an answer? Yes, my dear friends. Anything that gives hope? In this question?
Option B.
Huh? Where is the question? In electromagnetic wave propagation vector, this is the pointing vector, pointing vector, pointing vector. Electric field E, omega is the angular frequency. Then what is the value of the magnetic field? Yes, what is the answer?
Sir, is it IR1, sir, in option B?
Huh? It is 1 by omega, my dear friends.
Option B.
1 by omega. What is the value of magnetic field? Is K cross E. And K cross E, how do you get? How do you get? So, see, the speed of light is E by B. Yes or no?
Yes.
This propagation vector is actually not pointing vector. So, it's not given in that form. Okay. Anyways, the speed of light can be written by omega. This k is basically, I think they've misinterpreted this. If it was pointing vector, I had given you the formula of the pointing vector. Yes or no? You should have to use that formula. Which one? I think the question has been misinterpreted. This is the formula that I had given you. Pointing vector 1 by mu naught is E cross B. Do we remember this?
Yes.
Here, I think they have given it in terms of the speed of light or the wave number k, and that is why the answer is different. I will just check this question. I think there is something wrong with this question. I will just check this question and then I will come back to you again on this one. Okay, I'll just check this question again. I think there has been a misinterpretation somewhere. Anyways, let me ask you this question in the meantime. Remember, all these are questions from the shift in which some of you have appeared, all of you have appeared probably. This is 25th of Jan, shift 2, and I will not say anything. I'll give you the chance to do the needful in this one. An inductive reactance XL is equal to R is connected in series with the resistor R across an AC. Power factor comes out to be P1. Now, if a capacitor is also connected in series, ratio of P1 is to P2. I'll give you 2 minutes to do this. Option 2, 1 is to root 2. How did you get it, my dear friends? So, in first case number 1, your power factor cos of phi 1 is R divided by Z. R is R and Z is R root 2. Yes or no, my dear friends? So it is 1 by root 2. Do we get this?
Yes.
In the second case, XL and XC will cancel out each other. The power factor will become 1. Yes or no?
Yes.
So the answer is 1 is to root 2. Do we get this, or this has gone above our head? Saying bye-bye.
We got it.
Bye-bye. See,
Got it.
in the same paper, you got this question. So in just 2 class, we have covered 2 questions from your paper. Same paper. This is 30th Jan shift 1. The first question was from LCR. The second is from EM wave. I can see one more question from modern physics. One question from dimension. One question from gates. So one question from magnetic dipole moment. We still have to cover it. One question from YDSC. So 7 or 8 questions I see straight away that are still you can do even if you have not done anything in the past life. There's still hope. There's still hope. So what is the answer for this one? Total momentum transferred, yes. Total momentum transferred is E, total energy transferred divided by C. Perfectly absorbing. This is, let me write momentum as momentum because then you will get confused. Momentum. This is power into T divided by C. Power is this. C is this. T is this divided by C. And the answer that you will get will be this one. I hope you understand this. Yes or no? No, yes.
Yes.
There's still hope, my dear friends. There's still hope. There's still hope. Still hope. Still hope. This is from 31st Jan, shift 1. The last question for the day and the last question for electromagnetism. And I leave the less stress to you. In LCR circuit, current and voltage are in the same phase. Resistance of the circuit is 20 ohms. See, such questions are coming in JEE. This is not a question even worthy of a class 10th. May not be class 8. Class 8, 9 somewhere. Resistance of the circuit is this. Potential difference of the AC source is 220 volt. The current in the circuit is root over XA. What is the value of X? And the answer is, my dear friends, if you need to use copy and pen for this, it's useless. Your life is useless. Then the answer is, and the answer is, voltage and current are in the same phase. What does that mean?
Power factor is 1.
What will be the current?
That means like Z is equals to resistance.
What is the current? 220 divided by 20. 11 amperes. And 11 is the square root of 121. And I don't have to tell you how to find out the root of 121 or how to square 11. Because if I have to tell you that, that won't be my second year, my student, my son is in class 2. He knows the table till 17. So he can tell me what is 11 square. Anyways, so the answer is 121, and that finishes this part of our course. We are done with electromagnetism once and for all. And we are not going to come back because we will not get time to come back and revise this one. So now I leave it in the hands of the Almighty. And I hope that Almighty assists you. It's not about whether you know it or not. It's more about whether you can calculate it or not. You need to work on that aspect. And even 5 days, if you give half an hour each day, in 5 days, you will be as good as Einstein in calculations. The calculations which are required to clear JEE Main. On that fruitful note, I shall wind up this class. In the next class, we'll start with the structure of atom. We'll start with modern physics. Take care. God bless you all.